So let us take this question on the screen. Question number 4. The question is, prove that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius r is twice of r upon square root of 3. Also, find the maximum volume. So in this problem, we can understand that a sphere is given to us and the radius of the sphere is constant. So we have to inscribe a cylinder inside a given sphere. So when we say a given sphere, it means that the radius of the sphere is a constant. In this case, the capital letter R on the picture is a constant. And the cylinder that we are going to inscribe inside a sphere can have variable heights and variable radii. But our aim is to inscribe a cylinder of maximum volume inside a sphere. So we start with the variables. To solve this problem, we start with some equations. And in mathematics, without equations, it is actually impossible to solve a problem. So the first equation that we can have is equation 1, and that is simply using the Pythagoras theorem. Now, the next step is we need another equation, as many equations as we can get to solve this problem. So the next important equation that we can have is the volume of the cylinder, because we know that the volume of the cylinder is always changing. It is not fixed. We can change it anytime. Now, the volume of the cylinder is equal to pi a square times h. So that is the volume of the cylinder. And this volume is not a constant. It changes every time because h can change, a can change, until we get that cylinder which is of maximum volume. All right, now the next thing is we have to look at the variables. See the equation V equal to pi times a square times h. Here in this equation you have actually three variables, V, A, and h. So V is a dependent variable, and A and h, they are independent variable. Pi, we know it is a constant. So we know that whenever we talk about differentiation in mathematics, we always have the x-axis and the y-axis, two variables. One is the dependent variable y and the independent variable x. So in this equation, we cannot have three variables. To be able to use the concept of differentiation, we need to have only two variables. One, a dependent variable, and the other, an independent variable. Now, look at the last line on the screen. You'll find that the last part of the expression is an expression where you have only one variable, that is h. So in this problem, we are trying to solve by expressing the volume V in terms of h. If you want, you can also express the volume V in terms of the radius A of the cylinder. That is up to us. There's no problem in doing that. All that we need is to have one dependent variable on one side of the equation, and on the other side of the equation, we should have only one independent variable. So after that, what we do is we differentiate both sides with respect to h, because we have expressed the volume V in terms of the independent variable h. So we differentiate both sides with respect to h. That is the first order derivative. Now, after that, we differentiate again one more time from the value that you have got in the first order derivative to get the second order derivative. And we put dv upon dh equal to 0 to find out the value of h. Now, if you have done that, then you will be getting the value of h equal to twice of the radius r upon square root of 3. Now, after we have got the value of h, what we do is we substitute the value of h in this expression of the second order derivative of the volume. That is, we substitute the value of h in d square v dh square. So when we do that, we will have to check only for the sign. If we get a number which is less than 0, then we understand that the cylinder will have a maximum volume when h is equal to 2 upon root 3 times r. So it actually follows that way. Now, since we have already got the value of h, what we do is, in the last line of the equation on the screen, what we do is we put the value of h. And when you do that, what we will be getting is the expression of that volume, which is of maximum capacity. The volume which is of maximum capacity. So that you can do on your own, and I hope these things are clear enough and you understand well.